Hello and welcome to bmclounge.com. Today we are talking about control charts. And of course, control charts is one of the 7 basic quality tools. Now, if you're into reading and you would rather read about control charts than watch this video, go over to first link in the description, which is going to take you to a related article on control charts over at our official website, bmclounge.com. So first link in the description, related article, check that out. Second link in the description is equally important because that is the entire playlist of the 7 basic quality tools. And third link in the description will be the entire playlist of every single video that we have done on the quality management knowledge area. So 1, 2, 3 very important links in the description. Do check that out. With that being said, let's get started with control chart. Now, control charts will help you visualize how the processes are doing over time. So let's say, for example, you are the quality manager in a glass making factory. For a change, I'm not saying you're a project manager. I'm saying you're a quality manager because we are discussing a quality tool here. We're talking about control charts. So let's say you are the quality manager and you work in a factory which is a glass making factory. So a quick brief about glass making because it is going to help you understand control charts. So believe it or not, glass is made of liquid sand. Now that's correct. Glass is made of liquid sand. So you can make glass by heating ordinary sand, which is mostly made of silicon dioxide. So you can heat the ordinary sand and until it melts and it turns into a liquid. So you can heat it until it melts and it turns into a liquid. You won't find that happening on your local beach because sand melts at the incredibly high temperature of 1700 degrees Celsius. For our American folks, that is 3090 degree Fahrenheit. So that's when sand will melt and will turn into glass. Now, since I said you are the quality manager in a glass making factory, I thought it's good to tell you what your job is about. Now, let's say you are now making temperature readings of the furnace over a 24-hour period, because what is the temperature that you need to manage? You need to manage and achieve and keep the temperature of 1700 degrees Celsius. So over a 24-hour period, you take several readings, temperature readings of the furnace, just to see how efficient your process of making glass is. And when you plot that graph, the next slide is what you get. Let's head over to that. So this is an example of a control chart. This is how your chart will look. To your left here, you have the entries of the temperatures, and below you have the entries for the time. This is the time. So over a period of 24 hours, starting at around 9 a.m., you took your first entry in the graph, and you got this point here, which means it was about 1500 degrees Celsius. The furnace was giving a reading of 1500 degrees Celsius at around 9 a.m. And then each hour you took one reading and you plotted this graph. So this is how it works. Now, certain things that you need to know here. Number one is upper control limit, which is also known as UCL. You already know that at 1700 degrees Celsius, sand is going to turn into uh, glass. So the upper control limit that you are considering here is around 1800 degrees Celsius, because you don't want to unnecessarily burn the furnace and take the temperature above 1800 degrees Celsius, because that is of no use. Similarly, you have a lower control limit. This is also known as LCL, and this is about 1600 degrees Celsius, because the glass is made at 1700 degrees Celsius and you do not want to go below 1600 degrees Celsius, because then it is possible that glass might not be formed out of sand. So these are two important concepts of control charts: upper control limit and lower control limit. Now I know you're wondering, there are certain data points which are beyond the range of upper and lower control limit. And we'll definitely address that. But first, the mean here, the mean is around 1700 degrees Celsius, which is perfect because that's the average at which glass is made out of sand. So this is where we are. These are some of the concepts: the upper control limit, mean, and lower control limit. Now let's look into the outliers. First and foremost, data point out of control. So you have one temperature reading which is below the lower control limit, and even if it was above the control limit, this is known as a data point that is out of control. Now when this happens, we say that the entire process is out of control. Now you might be wondering, it's pretty normal to have your data fluctuate from sample to sample. But when 7 data points in a row fall on one side of the mean, I'll repeat that. When 7 data points in a row consecutively, when they fall on one side of the mean, that's an uncommon enough occurrence that it means your process might have a problem. So when you have 7 points, that is when you will feel and you should know that your process is out of control. You have a problem. So when you see this, you need to look into it and you need to try to figure out what's going on, what's wrong. And this is known as rule of seven, as you can see here, rule of seven. So rule of seven is an important concept from PMP exam point of view. So do take a note of that. I hope this entire example was clear. Data point out of control, rule of seven, upper and lower control limits, and the mean. Before we end the video, a quick reminder, you can head over to pmclounge.com/PMP study plan and grab a free 50 days PMP study plan. So that's all that we had in this video. Do hit the like button if you enjoyed it. It will be a motivator for us to create more content, and subscribe to the channel and hit the bell icon if you haven't done so already. Also, don't forget to check out the website pmclounge.com, your number one free PMP resource. Thank you and have a nice day.